Okay guys, this is our boot camp on types of bonding. So there's 4 types: giant metallic, giant ionic, giant covalent and simple covalent. There's actually a fair amount of information on each page here, and as there's only 4, what I'm going to do is ask you to boot camp each slide for 7.5 minutes rather than just 5. That'll come to 25 minutes in total, which is actually a little bit less than what we'd usually do. We'd usually do a half hour. So, this first one's on giant metallic bonding. In particular, can you pay attention to the words in green, because they're the words people always get wrong. When we talk about boiling a melting point, the ions, everybody always says atoms. And of course, in metallic bonding, there is no atoms, there's only ions, positive ions. Everybody also always misses out the word delocalized electrons. Note as well with the diagram at the bottom that I've done 1+ metal ions. Of course, if it was a group 2 metal, it would be a 2+ charge. Aluminium in group 3 would be a 3+ charge, and so on. So, 7.5 minutes, guys. Well, 6 minutes left. Off we go. Okay guys, just 2 more minutes left. Write out a few more times, especially paying attention to those bits in green. These types of questions crop up all the time. Thirty more seconds, guys. Keep going. Last bit. Okay, and this is giant ionic bonding. Again, make sure we talk about ions, not atoms. Believe it or not, in ionic bonding, we have ions. With the diagram at the bottom, again, don't forget to check with the charges. If you've got a 2+ metal or non-metal, obviously the charge will reflect that. 7.5 minutes then, guys, off we go. Two and a half minutes down, 5 to go. You can do this, guys. Keep on going. 4 minutes left, guys. Well, yeah, depending on the question, so these don't have features. Two more minutes. You always know what number you've got over the salt. There's 1 in the salt. And this is our first slide on simple covalent bonding with the boiling and melting point be specific to the question. So you could say that they're held together by intermolecular forces, but a much more specific answer and much more likely to get you the marks is to actually specify which intermolecular force. So there's only 3 to choose from, so try and think and make your answer specific to the question. So 7.5 minutes, guys, off we go. 1.5 minutes down, 6 minutes to go. Really try and think about what you're writing down. Don't just blindly write it down. Five minutes left, guys. Not long.
Go on, guys.
Come on!
That's team encouragement there for you. Three more minutes, guys. Don't forget that conductivity. It's going to be delocalized electrons. A really common mistake is people missing out that word delocalized. 30 more seconds, try and get it down one more time. Okay, wicked. So that was simple covalent bonding. And this final slide is about giant covalent bonding. You only get giant covalent bonding when you have pure boron, pure carbon, pure silicon, also silicon dioxide. There are other examples as well, but they're the four I would remember if I was you. Don't forget the bit in green is actually really important at the bottom there. That's something everybody always forgets. Graphite is a little exception in that it has delocalized electrons, which usually giantly covalent bonded things don't do. So that will conduct, whereas other giant covalent bonding materials will not. So, 7 minutes guys, off we go. Two minutes down, 5 and a bit minutes to go. Remember, really try and take it in as you're writing it down. Don't let yourself just kind of phase out and daydream as you do it. Really try and think about what you're writing. Obviously, that's the point, isn't it? To try and remember it. Try and get stuck in your grey matter. 3 minutes left now. Notice how similar the answers are with boiling or melting point for all of these types of bonding. First of all, you say what kind of thing holds it together. Then you say how strong that force is, and therefore how much energy is required to break it, and then you conclude by saying what effect that has on the boiling or melting point. It's the same thing every time. With conductivity, all you're talking about is, do you have something that can move and carry charge? And it's always either ions or delocalized electrons, or nothing, of course. Okay, 1.5 minutes. Try and get this down from memory 2 more times. Three more seconds. Try and get this last one down.
Ten seconds remaining.
Okay guys, so that was the types of bonding. Well done if you managed to get that all the way to the end there. I will see you next time.